NESGameMaker, Part 2. We will now be moving on from the input object to the camera object. But first, we need to make a pit stop over here at the async system event and grab our old friend, the gamepad control input object manager code. So let's get cracking on that. All right, just pulling up my code here. And actually, while I'm at it, just going to throw in here for debug purposes. Keep pressed, other, escape. For killing the game easily. All right, so you probably have seen me do this before for gamepad, or if you're not, yeah, you should have in the Mega Man tutorial. I had gamepad input in there as well. So in the async system event, the input, the input object, good, it is persistent. The system event triggers when the game detects a gamepad. So if you have a gamepad plugged into your computer, it will trigger pretty much as soon as the event is created. Well, not exactly. It's apparently it's somewhat more closer to around the begin event when it actually triggers. But anyways, so what it does is it creates a DS map that has an event type and a pad index associated with it. So in the case of there's a couple different events that can trigger the system event. But in this case, we're looking specifically for the gamepad detection event type. Because when the gamepad detection event type is created, it also creates a pad index number, which tells you where your pad is according to your computer. So you can then reference that pad directly. And we have a little show debug message to make it easier to see. All right, so what does that mean for us? What are we going to do about it? Well, give it a little bit of information. So we'll have a little switch event that says if the event type that was detected here is gamepad discovered, then do some setup, specifically if you have different controller types. So if gamepad get GUI ID, gamepad UID is equal to this number. So on your back of your controller, let me look on it. So I have a Power PC controller here. It has a model number, in this case 151891001, which should be translated into your, well, it doesn't necessarily mean that would be the number that's here, but you can capture this information and basically the same way you do here, because there's a pad information right there, actually. Gamepad get GUID. So you can plug in your gamepad and get your ID, and then you can say, okay, well, if it's this specific ID, then do some specific mapping for that specific controller. In this case, the PS5 controller, which doesn't seem to have mapping properly set up, so I have to make up my own pad inputs. So this would be the A button, the B button, the X button, the Y button, and this is according to what it would be if it was an Xbox controller. Left shoulder, left triggers, and then these would be the buttons as detected. Button 1, button 2, button 0, button 3, button 4, and so on and so forth. These are all sort of standardized inputs in the system. If you want more information about it, just go into the help file for gamepad_get_GUID and that stuff. Yeah, so this is mapping. You have to set up like a specific string that has the ID, the comma there, and then you have to get the description for it. And then you have a mapping, and you tack that on to the end of this string as well. So gamepad_test_mapping for gamepad ID, set it to be mapping. So yeah, you tack it on plus equal. And then after you set up your controllers, we have our axis dead zone. I set it to 0.1 and threshold 0.1 as well. These are our certain capabilities. So for axis dead zone, you always want to have like at least 0.1. That way you don't have a wiggle that causes weird input when you're not moving the gamepad axis around. If your gamepad is a little bit loose, and you want to have your threshold. This is basically how far down do you have to press your A button before it's considered pressed. And depending on some controllers can actually detect how far the A button is pressed. And then you could do sort of like half A presses, and then you could start trying to do Mario with Mario 64 with 0 A presses or something like that. Let's see. Then we have to assign and activate the game pads. So first player is using keyboard, global gamepad IDs, 0 is equal to -1. So as you remember our gamepad from the last video, our gamepad IDs. And we have this -1 here. And that's by default the value. Yeah, see right there, -1. So if you're using the gamepad, so basically if you're using the this already at -1, then set the gamepad ID for that location to whatever the gamepad ID that was detected is. But if not, then add it into our list as a different ID. That way it says, oh, well, we already have one gamepad plugged in, so now we need to put in a second one for second player, and another one for third player, another one for fourth player, and so on and so forth. And kind of the opposite when you lose your connection. So then in that case, if you lose connection, then finds the gamepad in this gamepad IDs and deletes it from the list. And return player 1 to using the keyboard if all the gamepads are unplugged. And like I said earlier in the previous video, if you want to use the keyboard by default, even with a gamepad plugged in, you would have to change this slightly. So it would, instead of being automatically swapped over to the gamepad when it detects one being plugged in, make it so that it doesn't swap to the gamepad until the player presses an input or something. So your choice. It's entirely how you want it. Now, over in the sprites, I have some game object sprites. You can set that for there. It makes it easier to remember what each object is. And real quick, I need to zoom that in for you, don't I? Make sure you get a look at that when it's zoomed in as well. And we're good to go on that end. Back over to objects. Let's create a group here. I call this game objects, because these are sort of persistent background objects that run the game. And we're going to need our object camera next. Create object. We have your camera. Let's give it a sprite. Give it the camera icon. Make it invisible and persistent. Give it a create. We're also going to need a end step. Make sure it's end. And a other room start. And let me pull it up over here. So you may remember the singleton check code I showed off earlier. Just if there's more than one of this object, destroy it. If you're programming properly, you shouldn't need that, but it's there just in case. Let's set up a state system for this. We have our cam modes, targeted and free. So previously I also had a fixed game mode, but I basically said, okay, well, fixed is part of free. Basically, they're both the same thing anyways in the long run. So I just combine them both in the same state at that point. Now we are going to have our properties. So in this case, we have our view width, 256, view height, 240. Display width is whatever your monitor's display width is, and display height, your monitor's height. Aspect ratio, I don't really use that, but it's there if you need it. Maximum zoom, in this case, I set it up so that it will be 4 is our maximum zoom level, or the floor of the display height divided by the view height. So, if your monitor is small for whatever reason, then set the zoom either to the max zoom -1, because I wanted it to be like a 3, really, is my main one. Mostly because I had this thing where, so if you zoom it, if your display height and your view height are able to divide evenly, you'd end up with a window that's the same size as the screen, and it would hide the top bar up here above the screen because it's not taken into consideration when it's making window size. It's just the stuff that's inside of the frame that's considered as part of the window size. So in that case, you wouldn't be able to close your game. So by doing -1, I prevented that from happening. You don't really have to have that with this here. Or you could change up the code a little bit more to make it even better. But you definitely want to have maximum of 1, because you don't want your zoom size to ever be less than 1, because that doesn't make sense. Window width, this would be the size that we want our window to be set to. Basically our view width times our zoom. GUI width would be view width, GUI height, view height. And throw in our camera macro here, view camera 0, because we're usually using the camera 0. All right, let's go and set up our properties. So we have our window size, set that to our window size that we want. Then we have we want to set up our GUI. You don't necessarily have to do that, but if you're messing around with the application or surface size, it will automatically resize the GUI to match the application surface. And in this case, we don't want to match the application surface because we're doing a little bit of extra interesting stuff here. So what we're going to be doing here is we have GUI zoom and our pixel density multipliers. So we're going to have our GUI size set to our base window size, which is also our view size. And that means that whatever's drawn on our GUI is basically drawn at scale. But we also have the zoom, so if you want to have a larger GUI, so if you want the icons drawn on the GUI to be larger, then you would make a larger you would make a large, so you make a smaller GUI size if you want them larger, and you would make a larger GUI size if you want them smaller. Yeah, it's kind of backwards feeling, but that's the way it works, because if you make the GUI larger, that gives it more pixels to draw with, which shrinks the stuff that you're drawing onto the GUI layer. I hope that makes sense properly. Then we have the pixel density multiplier for our application surface. So that would be our view width times the density multiplier. So this should be always multiples of 1. And what it basically does is these should always be whole numbers, I should say. What it does is gives you more pixels to work with. So when your pixel density multiplier is 1, that means your pixels that are being drawn are 1-to-1 with the pixels that you see. So a pixel that you see is a whole size pixel in the game. But if you then say give your pixel density multiplier a 2, you now be having 1-to-2. So 1 pixel is now broken up over a 2-by-2 area. So you would take, so 4 pixels on the screen would represent 1 pixel, and you can do that however many times you like. I wouldn't really go. You you shouldn't make your application surface size larger than 4K, because it eventually will give you an error because you'll take up all the VRAM on your GPU doing that. So typically around 4 times or 8 times is the most I'd go. If you have a smaller game, 8 times is pretty good. 4 times is pretty good for anything else. Why would you want more pixels to work with? Well, this is more for if you want to have sub-pixel movements for smooth rotations and for smooth movement and stuff. The setup to use the sub-pixels is kind of complicated at that point, so we're just going to kind of keep it at 1-to-1. Plus, that's the way the NES was. It was all 1-to-1 anyways. But yeah, if you want to be able to rotate your pictures with image angle and keep the image looking nice and crisp when you do that, you'll need to up your pixel density multiplier as much as you can, and that will improve your picture. That could actually be like a game option where you have smoothing or something like that in your options, and the more they up the pixel density multiplier, the smoother the game will look or something like that. Anyways, so that's a fun little treat. And then we have lastly center the window, which has to be done 1 frame after the creation of the object for whatever reason. So line 0, window underscore center. And done. 1 and done. Room start. Oh wait, I've been doing all this in the room start already. This should all be in the create event, not in the room start event. But the room start event needs this information. View enabled equals true. View visible 0 equals true. And camera underscore set underscore view size, cam to view width and view height. Just to remind you, please do not enable viewports, and whatever you do not click visible, and do not edit any of this. Otherwise, you'll start having weird reactions with the camera setup code. All right, so let's see what else do we need to do to get this working. There's a lot more to get the camera running that we need to be doing, but let's see, what's our timeline? We're currently at 18 minutes. Oh, we have plenty of time. So we're going to our state execution here. Oops, I accidentally cut when I just meant to copy. And we're just going to do event user state. And use user event 0 and our user event 1. Now, you might be asking me why in the world I don't use methods or something like that in 2.3. Well, the answer is because event user is still very convenient and works just fine. So if I had more than 15 user events I want to do with an object, sure, I'd go into methods or whatever at that point, but I don't need them. So I'm not bothering with it. Let's go back over to the create event, make sure I got all the important information. The only thing I don't have in there is the shaking stuff. Well, you don't need the shaking stuff for this game, so we're good to go on that end. You just need this, and we'll go over to user event 0. We have, if instance exists, target, calculated position that's centered on the target. So our target's X position minus the view width divided by 2. And our target's Y position minus the view height divided by 2. So that'd be X, Y. As far as it goes, room boundaries. This is from Mega Man tutorial. We don't need that anymore. Well, at least in this game, because we aren't actually using room boundaries in this game, I think. So we can clear that out. Our X should be clamped to the room width and the room height minus the view width and view height. That way we don't go outside of the view room. Position our camera at our XY position and then position the actual camera at the X and Y position. And you might be wondering why we bother with all this stuff. Well, like I said, there is shake code, and if you want to get a good shake that follows the player around properly without inaccuracies in position, you have to have the camera object and the actual camera position, because you'd be having this camera object moving around following the player, but then you would be applying shake to the camera's view position so that then it would give you the proper location the view should be shaking at and stuff. So, and as for the free state, it's pretty simple. Basically the same thing, just clamp me to the room and put me wherever my XY position is. And that is the camera object. Wow, that was quick and fast, wasn't it? So what is next on our agenda? We have our input object. We have our camera object. Oh, well, I actually want to come over here. And we'll want to eliminate that. You can actually test the game at this point. See if it works. And it does. Kind of. Because it's not zooming in properly there, I think. Window set size to window width, which should be view width times zoom. And zoom is either max zoom, which in this case should be 4 minus 1, so 3, or 1. You weren't being creative. Oh, wait. I haven't put the init object into the room yet. That'd probably be very useful, wouldn't it? So let's do that. There we go. Now it's zoomed in properly. So once we get over to the transition manager, that guy will transition us to the next room. And our stats, well, we don't actually use stats in this game anymore because it's now a redundant object due to the way that we can use structs to build a save file. And we are going to be using Music Manager as our final transition object to our final init object to get us over to the next room at that point. So I think we're pretty much done here. I'm just trying to come up with ideas of anything else interesting I can show you with all this. So I think we're pretty good. Remember, if you have any questions or comments, leave it in the comment section for the video. I'm pretty good at talking with people. And remember that I actually have a Patreon. If my code has helped you out a little bit, please donate a couple bucks my way. So thank you very much, everybody, and good luck with your programming.